Hi, I'm Kathy Hutton, Product Manager for 3M at DigiKey.
And I'm Kyle Borgerson, Product Manager for Texas Instruments here at DigiKey.
Today we're going to go over two great products.
And we'll use the TI boards to evaluate the 3M cables and provide a brief overview of our results.
The revolutionary 3M round conductor flat controlled impedance cable, 7700 series cable, is constructed of 30-gauge solid conductor and polyolefin insulation with a 0.025-inch ribbon cable laminated with a flexible foil covering. Termination is done by insulation displacement to a 0.050 pitch IDC connector or directly soldered to a PCB with a 95 ohm impedance.
The evaluation module we will be using is the LMX2594 EVM paired with the included reference Pro board. With an onboard oscillator, this setup only requires a 3.3 volt power supply to output a precision signal up to 15 gigahertz. Using the intuitive software GUI, we will show how easy it is to set up and adjust the output signal during testing.
We had a great journey traveling from cold and snowy Thief River Falls, Minnesota to 3M's facility in Austin, Texas.
3M invited us to their lab where we use state-of-the-art equipment to analyze the output signal through the 7700 cable. The LMX2594 is a high-performance wideband synthesizer that allows you to generate any frequency from 10 MHz to 15 GHz without using an internal doubler, thus eliminating the need for subharmonic filters. The LMX2594's low PLL noise floor of -236 dBc per hertz enables designers to improve radio sensitivity and spectral resolution. A frequency ramp generator synthesizes up to 2 segments of the ramp. The LMX2594 adds support for generating or repeating sysref, making it an ideal low-noise clock source for high-speed data converters. To start with the LMX2594 EVM, we'll first start on TI's product detail page, scrolling down to the provided software. After downloading the software, you'll come in and select your device. Today we're using the LMX2594. This will bring up the different options. To verify the USB communication, we'll go to USB interface. If you'd like to identify it, this will allow a blinking light to start on the board so you know which board is selected. After that, we come up to the default configurations and load the default mode. After any changes, we can also come up to the USB communications and write all registers. And you'll see the activity down in the lower left-hand corner. If you want to do any other adjustments, any other changes to the interface, obviously you have all your options here. Browsing through the user guide and the datasheet will give you all the different options as far as frequency changes or any of the other components to configure on the eval board.
From the output side, we used a standard ribbon cable versus a 7700 series cable, using 2 ends terminated and connected using 3M's 451 series socket mated to 3M's series 452 header measured at various lengths. In our first test, we compared the 6-inch cable assemblies, one made with 3M's 7700 series controlled impedance cable and one with standard PVC ribbon cable, with a data rate of 1 gigabit per second. With the standard ribbon cable, the eye-opening factor was 86%. With the 7700 cable, the eye-opening factor was 90%. On the second test, we decided to rev it up and push the data rate to 5 gigabits per second through the 6-inch cable assemblies. With the standard ribbon cable, the eye-opening factor was 32%, which is deemed unacceptable due to the data loss. The 7700 series cable had an eye-opening factor of 70%. We all were intrigued. Could we go faster? So we pushed the data rate up to 14 gigabits per second resulting in an eye-opening factor of 57% with a 6-inch assembly. Then we had to ask ourselves, how much more can we push the 7700 controlled impedance cable? 1 meter with 1 gigabit per second, the data rate resulted in an 86% eye-opening factor. With 1 meter at 5 gigabits per second, the data rate resulted in a 50% eye-opening factor. Moving up to 2 meters with a 1 gigabit per second, the data rate resulted in a 75% eye-opening factor. And at 2 meters with a 2.5 gigabit per second, the data rate resulted in a 53.5% eye-opening factor. And looking at the capability of the raw cable, 3M's laboratory testing has shown the cable itself can transmit up to 20 gigabits per second through approximately 9.8 inches with a 73% eye-opening factor. This is real performance that is attainable in either a pin 1 to pin 1 or a pin 1 to pin 10 configuration. So the cable is definitely flat, fast, and fit for IDC. Even when folded 5 times, the revolutionary construction of the 7700 series cable allows tighter folding than standard ribbon cable with minimal signal loss. In conclusion, the 7700 cable outperforms the standard ribbon cable. This fast, flat, foldable, and fit for IDC 7700 cable is designed to accommodate tight spaces with minimal impact to performance.
We'd like to thank 3M and Texas Instruments for their collaborative effort in this video. Using the TI EVMs and the 3M cable, we were able to get great data that we can relate to real-world applications.
All Texas Instrument products and 3M products, whether it's the raw cable, custom lengths, or pre-made lengths, are readily available at DigiKey.com.
Thank you for watching.